we heard a really interesting talk from Tim on New, which is a programming language, and we're about to hear a talk from Dave, who's going to talk about reactive Cocoa. And this talk is actually pretty interesting being in between these two because these two are larger abstractions, and tonight I want to talk about three much smaller abstractions that I think will still help you write expressive code. And hopefully by the end of the talk, you'll be convinced that three small tools can help you go a long way. And so with that, I'd like to start by actually clarifying what we mean by expressive, right? So we're all here tonight because we care about writing expressive code. But what does that mean, right? So for the sake of our discussion tonight, I'm just going to take it to mean writing clear, concise, and convincing code. I think we all agree that this is something to strive for, right? We all want to write this kind of code. We also recognize that it's not easy to write expressive code. Oftentimes it requires more thought, right? It takes more time to write expressive code. And the thesis of my argument tonight is that small tools can go a long way. That the right building blocks can help you a lot. And at Prismatic, as Ian mentioned, we've borrowed a lot of ideas from functional programming and Lisp, and we think that we've built a bunch of these abstractions that can really help you a lot as well. And so I'd like to share some of them with you tonight. And to motivate these abstractions, I like to talk about some common tasks that app developers face. And these tasks all of us have done if you develop an app before, and that's manipulate data, communicate with your backend APIs, and also manage your state, right? And typically, when faced with these tasks, what do? Well, you write imperative code to manipulate data, you use callbacks to communicate with your API, and to manage your state, you manually synchronize because of concurrency issues, or you use KVO, or NS Notification Center, or the likes, right? And chances are, if you use what comes stock with the platform, you probably come away like a bit like meh, yeah, that was okay, it got the job done. But I think if you choose to use a few abstractions, and if these abstractions are at the right size, you can actually write very expressive solutions, and you actually come away fairly fulfilled. And some of these abstractions I want to introduce tonight come from functional programming. And specifically for API communication and state management, I want to talk about promises and atoms. All right, and I'm going to go into each of these three in detail now. I'm going to motivate each of these areas using parts of the Prismatic app. So there's something actually backing each of these abstractions, and you'll get to see it. So starting with data manipulation using functional programming. How many people have seen code like this? Or have used functional operators like these? So you get an array of x's, right, an array of something, and then you use the map operator. And you say, okay, for each x, I have something that maps to y. I want to filter out the ones that shouldn't stay in my list. How many here have seen code like this or can infer what this is talking about? Okay, so like half or over half of this. So that's what I figured. Like if you guys care enough to come to the event tonight, you probably have had some desire to learn basic functional constructs. So I don't want to bore you guys with these things. And needless to say, we also have our own implementation of this category that I'm sure is scattered over your code bases. And this for us is a NS array plus sequence category. So what we can do is, for instance, take an NS array and just map using a transformation function, right? So you can take a sequence and map it with a map function, or you can filter with a predicate, right? So please filter away the things that do not satisfy this predicate function. Or you can say things like, hey, does every element of this list satisfy this predicate condition, and so forth. But this is actually fairly standard by now. There are popular open source libraries like _m. If you come from JavaScript, there's _js that do very similar things. The only difference that we do in NS array plus sequence that we actually intend to open source soon is that we want to stay very close to the language. So we did it as a category so you don't have to wrap things and unwrap things later. So with that, if you're curious about how these things work, I actually prepared a ton of slides motivated by our activity feed on the Prismatic app, and actually show you how we implemented it using functional abstractions. So I'm going to skip all that because over half of you guys have kind of seen this kind of stuff. This is actually like how I would implement it at Lisp, and how using some very simple Objective-C operators, categories, you can actually still remain very expressive while staying in the language. And for those of you who have seen this, which is over half of you guys, I guess what functional programming really forces you to think about is data. So really one of the tenets of functional programming is that data should be unadorned, and that you should be thinking about functional transformations. That really programming at its core should be data focused. And why is this a good idea? Why is functional programming forcing us to feel that way? Or why is this something that we, as functional programmers, tend to really hone in on? I think the picture that we have mentally is something like this, right? The TV here is unfortunately a bit desaturated, but here's, it's a mess. The world's a mess, basically. There's a lot of crap in the world, especially on an iOS platform. You have to deal with all sorts of really, crazy APIs and whatnot. But as much as possible, you want to view your program as a beautiful, perfect bubble, right? You want to shield yourself away from all the crap that's out there. You still have to talk to it, right? Which is what these electrodes are doing here. But as much as possible, inside your app or inside a class or a method, you want to be as side effects free as possible. You want to be talking about data and transformations of that data into other data, right? And you want to be as pure as possible within this bubble that you've created, on top of this messy world. And I argue that if you think functionally like this, you shouldn't be restricted to convenience functions on NS collection classes. You shouldn't be restricted to map and filter, right? I mean, all the examples you see are things on NS array or maybe things on NS dictionary. Can we do better? And I argue that with this same mindset, you can actually apply data-focused programming in views. So to motivate this, I want to talk about V, which is another open source library that we're working on, and we plan to release it soon. In particular, I want to talk about a category called UI view plus V. And to motivate this category, I'm going to talk about our full view on Prismatic. So this is our app. This is a full view. This is actually a really cool story about an origami door. And when you push it, it doesn't actually slide out. It actually just kind of covers the hole. It's pretty cool. But this story, I want to focus on the byline, which is the publisher and timestamp, the title, and the body. I want to just talk about how we laid these out, right? So, for those of you who don't use Interface Builder and lay your views out manually, which probably a fair amount of you guys do, you might start by doing something like this. And this is certainly how we started. We're not trying to be condescending. This is where we started, and this is where we improved from. So you would say, okay, I have three things I want to lay out. I have the byline, I have the title, and the body, right? Byline, title, and body. And you go, okay, I'll have an offset. I give it a start X and start Y. And for each of these subviews, I'll loop through, and I'll manipulate its frame origin, right, while keeping track of the start Y position, right? So I'm kind of laying things out. Is that kind of clear? Okay, everyone's on the same page. And argue this is very imperative, right? You're actually maintaining start Y as a state. And I think that's actually not the worst part about this. Imperative is actually, there's nothing bad against imperative per se, but for this implementation, I argue what's bad about this is that it hides intention, right? If you think about what you want to do when you want to lay these three things out, what you really mean is you want to, you got three subviews, you want to lay them out vertically with an offset and padding, right? And if you apply data-focused programming, if you think functionally, you go back to this diagram, you think, okay, well, what I really mean is, I have data input, that's the three subviews, the vertical layout, padding and offset, and the Y, I want three position subviews, and at the very end, I want to have the side effect of actually showing these subviews on the parent view. Right? So if you reify these intents into into layout information, and you think about what functions should be, and for us, we've created this thing called layout subviews, given a layout info, then I think the code becomes very clear, and I'll show you that in a second. Just to be clear, layout info is all the intentions you have with laying out the three subviews. So you have things like, should I add this vertically or horizontally? What's the inter-item padding? How much should I offset by? Do you want these things to be aligned centered, left, right, top, middle, bottom, and so forth? And then the two functions that I want to talk about concretely are layout subviews and at subviews with layout info. Okay. So that code that you saw, that imperative mess that you saw before, turns into something like this, where you say, please add subviews, byline, title, body, given this layout information. And this layout information is simply, given an offset, given an add direction, and given an item padding. Right? Here I'm using code block evaluation, which is the new hotness, according to NS Hipster. It kind of, it's nice. But right, what you see here is the X is this, byline, title, body, and this block. And that's the X. And the y is actually collapsed because I side effect immediately with this add subviews. But I argue that this is actually a lot cleaner. This is a lot more declarative, and in general, a lot more functional as well. So the first abstraction that I want to talk about was this subview layout abstraction. And hopefully you guys will use it when we release V. So the second thing I want to talk about is everyone doing okay? Everyone kind of following still? Cool. No one's falling asleep. It's kind of a little chilly. Second thing I want to talk about is promises. So we all have to deal with APIs, of course. Like our apps don't live in isolation. We have a backend to talk to. And whenever we have a backend to talk to, we have to deal with the network, right? And the network is great. It has lots of delays. You have to coordinate asynchronous calls. And when there are errors, you have to handle them. It's a joy to work with. But it's a fact of life. Life sometimes just like this. It's painful. And I want to illustrate why it's painful with another example from our app, which is the feed view. So this is Prismatic. We are about interest, and we help you discover interest by presenting you interesting contents, right? So this is the Objective-C feed. And for this interest, you can follow it. There are followers of this interest, and there are stories, right? I want to focus on this followers button. When you tap on this button, we push onto a nav stack this table view, right, of all the followers of this topic, right? Everyone following, it's pretty straightforward. So how shouldn't you implement this feed header? I want to focus on this button, actually. So you might be tempted to do something like this, right? In the constructor of this feed, you give it an interest, and you instantiate this button. And then when you get the interest, you make the API call, you wait for the data to return, and then you populate the number of followers you have here, right? And then later on, you say, OK, well, I add the stat count. As soon as the data is ready, I do the target action, right? So you add target somewhere else in the code, maybe like 100 lines down. You add this other method, and then you have to make sure you keep enough state about what happens when you click on this through an instance variable, which is actually kind of atrocious if you think about it. I mean, why do you have to keep state to communicate? And that's because target action doesn't offer you custom event payload. But in any case, so you do this thing, and then upon touch up, when you touch this button, you issue another API call, and when the data comes back, you create the view controller and you push it onto the nav stack, right? So some of you might do this. And for those who are observant, it might be like this is horrible because, well, like why are you issuing an API call? You're blocking the UI here, right? So you'd be like, OK, fine, maybe a better version of this is you just pass in the URL immediately to the next view controller, right? And then this view controller will understand how to issue the API call. So at least you get to push the view onto the nav stack immediately. But you see, with this abstraction, or with this way of doing things, this way that comes stock with the tools from the framework, there are a couple issues. Number one, this target action plus the instance variable is really kind of unnecessary if you think about it. And the second thing that is a bit more subtle is that if you choose to go the faster route of creating a view controller with a URL, you actually have a bit of an inconsistency with the API for the constructors. Because sometimes constructors will be constructed with domain objects, like in this case an interest, and sometimes it's being initiated with something that's not semantic, like a URL. And that's actually a more subtle kind of minus about this approach. And so again, there are a couple issues with this. Your chase and control flow. There's an inconsistent constructor API, and you have to make a trade-off between that and something that's slow. And so the abstraction that really kind of leads you out of this quagmire is something called promises. How many here have played with promises before, have heard it? OK, great. So most of you guys. So you guys probably are familiar with promise. Promise is typically a result of an asynchronous operation. It is value that may or may not be fulfilled. That's what a promise is. And the way that we would implement, and just to be concrete, this is the API of a promise. A promise may or may not be fulfilled. In order to fulfill a promise, you deliver it with a value and an error, or optionally an error. And when a promise is fulfilled, this callback gets called. Right? That's it. That's all promises. Of course, with the A-star spec, there's a bit more, but at its core, this is it. So I argue the right way of doing that follow-respondent interaction is something like this, where your view controller gets instantiated with a promise, and you immediately create this callback with value. When the data comes back, you do the same thing with setting the number. I kind of snuck in something else here that we have internally on touch-up, and this is just a bit of nicety to not have to do the target action, not having to share the instance variable. So on touch-up, you create another promise, and you feed that into the next view controller. So you're always talking semantically, which is the promise of the domain object. And so I think this is a big win, right? The small abstraction has given us a huge win in this really gnarly problem of API callbacks, or of network APIs. And the wins that it gives us are, it's a declarative, it gives us a consistent constructor API, and this fast UI response. You don't have to make any trade-offs, right? And this is, and moreover, actually, promises give us more. It gives us chaining. So for those of you who have to wait on multiple API calls, you kind of get into a callback hell. With promise chaining, you only have to issue the callback one time. You only have to have one callback in your entire chain of promises. It also helps you coordinate it. Let me illustrate what I mean here. In promise chaining, this is oftentimes something that you do in your app. You want to authenticate your API, the user. And after the user's authenticated, you might be pass back a user object. And then you might want to do something immediately with the user object, right? So as opposed to having a nest callbacks, and having, going through multiple levels of indentation to figure out what's going on, it's something that's declarative as authenticate, then feed for user, right? So I argue this is a lot more declarative. Another thing you can do is map. Kind of taking from NS array plus sequence, that abstraction over there. You can say promise map, and then for instance, in this case, we don't care about the feed, we care about the items in the feed. So you say the feed promise map and a transformation function, and I get a promise back. So that's a fairly seamless way to transform one promise to another promise. And as for coordination, we have something like all, right? So many times in your API, you have to wait for the return of multiple API calls. And so in this case, you can say promise all and give it a sequence of API calls. And the response, the callback, will be called with an array whose index of the array corresponds to the value of the API call, right? And if any of these functions error out, the first of them, it will be early term, like the entire chain will be early terminated, and the first error will be returned with the second argument here. So this is actually really, really nice, and it helps us a lot with network RPC. So that was the second abstraction I want to show you guys. Everyone's still awake, this is good. And onto the third abstraction that I want to introduce, and the third thing I want to talk about tonight is state management through atoms. Atoms might be promises, and NS array plus sequence might be more familiar. Atoms is actually an idea we borrowed straight out of Clojure. Maybe some of you have seen it for those who've done Clojure before. And to motivate atoms, I want to talk about how we, in return to the full view. So again, this is the full view of our app, and there's I want to talk about the save button in particular, this little star at the bottom right. What does the save button do? If you click on it, it does a little rotation, it's kind of cute, and then it actually saves the story to your reading list. So if you have Pocket integration, if you have Pocket on iOS, this will save it to your reading list, and that's actually one of the most requested features for our app. So I want to talk about how you implement this, right? So let me first start by how you shouldn't implement this. You might have seen code like this. This is how we started writing this kind of code. You say, well, I'm going to create a save button. When I select it, it's going to be dependent on whether the document is saved already, right? And when you press on the save button, you call this target action save button pressed, and you do some animation, and you reflect that state onto the doc. So this is actually pretty basic. But where it gets you in trouble is when you need to issue the API call, where you have to coordinate state. So this code's the same. When you press the button, you actually have to do something. You have to save the doc onto the API. So what happens then? You go, okay, well, I'm going to issue an API call, and then as with networks, shit might happen, and you might be unsuccessful, and then when shit happens, you have to revert, right? So you kind of duplicate your view logic twice. Again, you have to communicate through an instance variable. Moreover, I still haven't shown you how we would propagate the safe on all local instances of the dock. For instance, the dock lives on the full view, it might live on the feed view. There might be multiple view controllers who wants to know the state of the dock. So again, some of the issues are coordinate state through the UI, and there's some awkwardness with the API. So I think Atom is a huge win here. And Atom is basically two things. It's a thread safe mutable and it's a watchable. Concretely, watchable just implies whenever a state changes, please notify me. Right? It's kind of like KVO in a sense, but it's more direct. So you register a function with the state change. Whenever a state changes, you're gonna be told, hey, here's the old value, here's the new value, and you can remove the watching too. And an Atom, remember, is a watchable plus mutable, so you can actually, in a thread-safe manner, ask it for its value and update its value. And with that, I would argue the right way of implementing the save button would be something like this. You grab a save Atom, and we have one for each dock. You initialize the save button as before. You have to do some weakify, strongify business because this block, you don't want to retain the reference here. But on touch up, you toggle the Atom, right? And Atom, all you have to do is on change, when the Atom state changes, so all the Atom is just encapsulating that Boolean of whether or not the document is saved. When the state changes, hey, just render the view, right? So now there's one source of truth, and it's Atom. And so it's the UI changes the state, and then, the interaction changes the state, and the state changes the UI. So it's actually fairly clear. And you might say, like, what about network, right? I'm going to cheat a little bit, and this is actually fairly similar to what we have in our code. All we got to do for network is just not use an Atom, but use a server-backed Atom, where when the state changes on the Atom, we actually issue an API call and reflect that change on the back end as well. So altogether now, you have a watchable, you have an Atom, and for a server-backed Atom, you just need to set a server call as well, so to handle the case where you want to update the state of the Atom. So I argue this is actually a huge win for when you have these small kind of toggling of UIs or state that you want to wrap and you want to have network effects, or you want to have an API call that's backing it. So that's it. Those were the three small abstractions I want to introduce. And hopefully, armed with these abstractions, you can keep coding Objective-C. And thanks for listening. Yeah, all the UI stuff's fully tested. Like we lay things out. We can check that they're correct.
And how do you supply blocks, or which framework are you using?
Say it again.
Like how do you supply on blocks? How do you capture?
The blocks. Oh, capture blocks. Well, it's more like you have a function. So, I mean, what I showed you was a function. So you just have input output, and you just verify the output of it. So you give it the layout subviews method you're talking about.
Let's say you have like async call to a server.
Oh, you have an async call to the server. Oh, so internally we use Kiwi for some of the async testing. So we wait eventually for the effects to show up. Any other question?
How do you deal with type safety for all the block types you've got there? I know there's a lot of IDs.
Yeah.
Sometimes the input and the output could be different if you declare it incorrectly.
Right, so that's one of the unfortunate things with Objective-C. There's no generics, and so you kind of just have to be careful. For our APIs, we actually auto-generate most of the code there. And for a lot of our domain classes, for things that are generic, that could be generic, like collections, we actually have comments. They're auto-generated, so we know that we're dealing with a NS array of say, docs. But yeah, there's no type safety, unfortunately.
So I'm thinking sort of, Backbone?
Mm-hmm, yeah.
The way Backbone handles data saving it is, you mentioned you wanted to have everything data-centric. So Atoms seemed like an abstraction away from data-centric, where it would be easier, I think, for another developer to read your code by having the model know how to save itself to the server,
right,
and then have callbacks on the model itself.
Yeah, so that's actually a pretty interesting question. I think Atom is a very light layer on top of unadorned objects, unadorned state. So typically in OO, you wrap everything in a class, in a model, right? And each model you endow it with a lot of serialization and knows how to talk about its own domain business logic. In Atom, you have a very, very light wrapper on a Boolean or on an array. And so you don't speak of docs, you speak of, or you don't, you might have docs which encapsulates a list of doc documents, right? And that will know how to, really you're just providing, incomplete NS array implementation sometimes. Whereas in Atom, it just wraps it and then you just tell it, hey, this is how you should save yourself, or how you should persist yourself. So it's a different approach. Cool.